All right, we are in AP Stat. We are in Chapter 3, and I wanted to go over some practice problems of displaying and describing categorical data, basically, is all I wanted to make sure that we did. So, kind of going over some of these practice problems to see what we got. So, again, feel free to pause the video, jot this stuff down, and keep going through as we can, but I'm going to try to get through these as fast as I can, just to give you as many practice problems as I possibly can. But we got a pie chart, right? Summarizes the genres of 120 first-run movies in 2005. Is this an appropriate display for the genres? Why or why not? And which genre was least common? Well, it's hard to tell anything. I mean, if I was to scan this, it kind of looks like the green and the blue are, maybe the green's a little bigger, maybe comedy's a little bigger than action, right? So if I was to go with least common, it looks like thriller is the least common off the top of my head, but is it completely appropriate looking at this pie chart is basically where we're at, right? And a pie chart seems appropriate for the movies, right? I can kind of divvy out the 100% there of where it seems people are at, but each movie has only one genre, and the 120 movies constitute a whole pie. So that's out of 120 total movies. I can see them. However, because of the percentages of each type of movie, it's difficult to compare the ratings. All right? So how am I comparing how they are rated? Right? Which one? The pie chart summarizes the genres of the first run movies released. Is it an appropriate display? Sure, I guess there's more. What is it going to tell me? There's more here, but which genre was least common? I don't know. It's not clear whether action, adventure, or comedy is the most common either, right? Just how am I supposed to know? So thriller looks like it happened least, right? It has the smallest region in the chart, okay? Taking a look here at the pie chart again now, it says you have a pie chart assigned to 120 first run movies released in 2005. Is this an appropriate display for this data? So it's looking like G is the smallest amount, and all we know is that it looks like PG-13 had the most. So most of those movies were PG-13, and which was the most common rating. So same idea, as you're looking at this, a pie chart, it could be appropriate to see, which ones came out of the 120 movies. It looks like a majority of them were PG-13. Each movie has only one rating, right? It's only one little rating that's coming out if we're doing it that way. So it'd be the whole pie. The percentage of each rating are different enough that the pie chart's kind of easy to read because it's not too close, so I can't really tell. But the most common would definitely be PG-13 because it has the largest region. Just making sure you can read these pie charts fine. So here's a bar chart, right? Summarizing the movies, right? Which genre was the most common? Well, looking at it this way, now I have numbers on the side. So as I'm looking at this, I don't necessarily know what the numbers represent, but I would say comedy is definitely more than what action and adventure are. And it's easier to see that in the pie chart or the bar chart. To me, it looks easier. So I'm looking at this. Comedy is the highest bar. So it's the most common, right? This is easier to see. Now, could we still use a pie chart? You can still use a pie chart, but you want to use the term, the display that is the easiest for people to understand what's going on, right? The percentages are so close that the difference is nearly indistinguishable in a pie chart, but I can kind of see it a little clear here. All right, so here's a bar chart summarizing the 2005 movie ratings that we just saw, which was the least common rating. Looks like G. I can see that point blank. And an editorial claim that there's been a growth in PG-13 rated films that, according to the writer, have too much sex and violence at the expense of G-rated. All right. Then the G-rated ones are basically good, clean fun. The writer offered the bar chart below as evidence to support his claim. Does this support his claim? Well, I don't know if there's more, as in, are they taking away from G and adding it to PG? But I do know that there are obviously more PG-13 movies than this. So there are more movies that are like that. So the least common is definitely G because it is the shortest bar. The bar chart does not support the claim though, because these data are for a single year. I don't know what's happening over time. Maybe last year this wasn't as big or as drastic. We have no idea if the percentages of G and PG-13 movies have changed either. I don't know how much would have came from here to here, so it makes it a little more difficult for me to make that claim to say, sure. This year, yeah, sure, it looks like there's more PG-13 than G. You're right. But was it always that way? Has it been trending that way? I need to see more years to figure out what's happening. An article in the winter 2003 issue of Chance magazine reported on the Houston Independent School District's magnet school program. Of the 1,755 qualified applications, 931 were accepted, 298 were waitlisted, and 526 were turned away for lack of space. Find the relative frequency distribution of the decisions made and write a sentence describing it. So, point is, there were 175 qualified applicants for the Houston Independent School, right? Those were all the applicants. 53%, which you could basically just get by taking them and dividing them, right? 53% were accepted. 298 divided by that were waitlisted, which is 17% if you divide them. And 30%, 526 divided by that, were basically turned away, right? So find the relative frequency distribution. I didn't need a table, didn't ask for a table, just wanted to know what the frequency distribution, the relative frequency distribution, which is oftentimes them just saying, what's the percent? Is all they're saying. What was the percent when you divide them of each? There you go. Here's your next one. Centers for Disease Control and Prevention. All right. We got our list for 2004. This is the cause of death and the percentage of them. It says, is it reasonable to conclude that heart or respiratory disease, all right, heart or respiratory disease were the cause of approximately 33% of the U.S. deaths in 2003? So, this is a list cause of death in the United States during 2004. So, in 2004, it's looking like this is around 32, right, that's 32.3. So, can I conclude that? I don't know. We'll see. What percent of deaths were from causes not listed here? Well, I can add these all up. And then after I add these all up, I can see, because it's supposed to be up to 100%, whatever's left over. And can I create an appropriate display for this data? Well, it says, is it reasonable to conclude that heart or respiratory diseases were the cause of approximately 33% of deaths in 2013 or 2003? We're going with yes. It is reasonable to assume that the heart and respiratory disease caused approximately 33% of deaths in 2004, since there's no possibility for overlap. Now, this is in 2004. So what they're saying is each person could only have one cause of death. All right. Can't have other causes of death. So what they're implying is if it's around right here, if I take this and I kind of add those up together and get roughly 32.3 causes of death is where we're at each year, they're concluding that it should be around the same, right? Is it reasonable to conclude that heart or respiratory diseases were the cause of approximately 33% of the U.S. deaths in 2003? All right. And they're saying, yeah, it's reasonable to assume that heart and respiratory disease caused approximately 33% of the U.S. deaths in 2004, since there's no possibility for overlap. Okay? You can only die once, what they're getting at. The part B, what percent of deaths were caused that weren't there? Since the percentage is listed, all of these add up to 66.4, 33.6 were unaccounted for. Okay? And then it says, create a graph. You could create a pie chart. That would be fine. You could create a bar graph. All right, pie chart is a good choice with the in conclusion of other, because if I do a pie chart, whatever's left over, I could make that big hunk be other. I could do the same thing with a bar graph. Just make one extra column that says other, and that would be fine as well. So here's roughly what one would look like, and then there is the other piece of the pie, but there is each thing divvied out. Okay. Data from the International Tanker Owners Pollution Federation Limited give the cause of spillage for 312 large oil tanker accidents from 1974 to 2006. Here are displays. Write a brief report interpreting what the displays are. So what they're saying is all large oil tanker accidents between those years, 312 of them were displayed here. Write a brief report interpreting them. It looks like that more of the accidents, whether I look here or whether I look here, all right, and it's a mix between them both. Groundings, causes of oil spills. We have number of spills, 118 of them were caused by grounding, right, over here. And then it says collisions are the next highest. I don't know why the color coding system changed from the looks of it between them, but it seemed to. But I think they're supposed to represent the same thing, but it looks like they are the most reasonable causes, whether there's collisions or groundings when you're looking at this. So it says the bar chart shows that grounding right here is the most frequent cause of oil spillage out of the 312 spills, and allows the reader to rank the other types as well. Like I can visually see it easily. That's the second one, the third one, the fourth one, the fifth one. If being able to differentiate between those close counts is required, I would definitely use the bar. But the pie chart is also acceptable as a display, but it's difficult to tell whether, for example, there's a greater percentage of each of these, which one is greater, right? If you want to showcase the causes of oil spills as a fraction of 312, you would want to use the pie chart. Okay. When I come back, I will take a look at some more of these practice problems with global warming.